Hi, everybody. This is the part of the course that usually happens in person, but in your online section, we have these videos. The upside is that you can work at it on your own time and at your own pace. The downside is that I'm way more boring in videos, and there's no opportunity to ask questions or get clarifications. So let's set the social contract on these videos now. I'm going to try to make them quick and to the point, knowing that you can pause and go back and look again. And you must promise to not hesitate to reach out to me when you run into a roadblock. This will probably happen more on the assignments than on these exploratory lessons, but all the same. The point of these exploratory lessons is to learn how to use spreadsheets to apply statistical concepts to data. As you work on them, you will see a green bar at the top showing your grade and your progress for this exploratory lesson. If it isn't working, just click on it up here at the top, this gray bar. Right now we don't have anything, but we'll see it populate. And give it a minute to run, and you'll see your grade update. Once you get 20 out of 20, you're good to go. Okay, let's get started on this spreadsheet on our first exploratory lesson. So we have here on the left-hand side this data from the American Community Survey. This is done by the Census Bureau. They do it in off years where they do a very large survey to try to estimate the population of the states. And then every 10 years they do the actual census to count everybody up. But these are their population estimates for 2021 for each of the states. And I've even added the little flags for each of the states. We have a couple non-states in here, Puerto Rico and District of Columbia. So we've got a few extra in there. I think that's it. Yeah, so we have like 52 states of data. And we're going to calculate some summary statistics for them, which you've learned now in the chapter, in the work that you've done. So how do we do it in a spreadsheet? So first things that we're going to calculate are the measures of central tendency, the mean, the median, and the mode. The mean, the median, and the mode we can calculate. The mean is the different one. So the mean, which we also call the average, the function in Excel is average. So I'm going to type in this cell equals average and then this open parenthesis. And you'll get this. You'll get this help dialog here. If you don't see it, sometimes you won't see it, you'll see this question mark on the left-hand side of what you're typing, and you can click that and it'll appear again. These are really important, and as we go along, I'm going to assume, actually, that you are going to look at these and learn from them. That'll happen more on the spreadsheet assignments, where you'll be asked to use a function that maybe we haven't used in class yet. And you can click this little down caret and it will open up all this information about how this function works. And it tells you, returns the numerical average value in a data set, ignoring text. That's super helpful. That tells us that we can have a really nice shortcut. You can see how they formatted it in here, this A2 colon A100. Now, we've talked in the introduction about like how these cell references work. So A refers to the column, that would be column A, and then 2 would refer to the row, so it would look in A2, which right now is actually this whole block of things. And you can include multiple ranges, and it'll take the average of all of them. Okay, so that in mind, we know that it will ignore text when it calculates the average. I want to get the average population. The population is in column C. Now, what I could do is select all of these. I can select them all, and it'll put in there for me C4 colon C55, which is all of those. I can also choose to type that, C4 colon C55, and that works too. Or, the nice shortcut is, I can just click on column C, and you'll see what it put in here is C colon C. It doesn't have a row reference, which means the first one, it's going to start at the very top, and then the second C reference, it will go all the way to the bottom. So you can see selecting column C just selects the whole column. Since it's ignoring the text, it's ignoring the words 2021 Population Estimates American Community Survey and the word population, it still knows what to do and gets it right. You close the parentheses, you hit enter, boom. We have the mean. This is the average population in all of these states. 6,445,333.25 people. Awesome. Cool. The median finds the middle number. This is where like spreadsheets are super helpful. Medians are really hard to calculate. You got to put everything in order, and then you've got to figure out what the middle number is. The spreadsheet will just do all that for you. So the function here is called median. So you type in median, and we're just going to again select column C, and column C populates there and gives us 4,377,774.5. So that 0.5 is telling me we must have an even number of states, which we do at 52, which means it took the average between two states. And that's why we're ending up with that 0.5. Okay, now let's do a hard one. And you can see here my grade has populated. If I click this, it'll sort of run, and you'll see it kind of spin, and it'll update my grade as you go along. You don't have to click it. It'll do it automatically, so don't feel like you got to click it all the time. But there it is. So we've got 2 out of 20 points. We're doing great. All right, the mode. This one is going to be different. So there is a function called mode, and it returns the most commonly occurring value in a data set. If I select column C, I get this. The mode cannot produce a result. No values occur more than once. So I get this error, not this kind of hashtag not applicable. And then if you click on the cell, you'll get this little pop-up box that tells you, when you hover over, what the error was. And that's helpful. It's telling us why it's not working. So as you work through spreadsheets, just know it's trying to help you. These things are all information you're supposed to look at. That makes sense. No, there's no observation that appears more than once. There is no mode. That's why the mode kind of sucks. Sometimes it doesn't exist. And so when we look at the states, yeah, it's no surprise that none of these have the exact same population. But I could make the mode useful. It is a measure of central tendency, and I kind of want to know, like, what is the most common thing? What does the typical state look like? It's got an average population of almost 6.5 million. The middle state is at 4.3, almost 4.4. So that's telling us that there's some really big states like California that are pulling that average up. But half the states are smaller than this population. And I kind of want to know, like, what's the most common thing in population? So obviously doing it to the person is not going to deliver a mode. But we could do it to, like, the millions. How many states have a population of about 3 million people? How many have a population of about 4 million people? Which one is the most? So let's embark on that little journey. I'm going to use this little area over here. You do not have to follow along with this just yet if you don't want to. You can just watch this because what we're doing here in these little yellow cells isn't going to matter. We're going to delete it in a minute. But what I could do here is round my population. So round will take some value and round it to a certain number of decimal places. Now, of course, like if I do that and I put in 3, what it kind of does here, it doesn't show me these decimal places yet. I can expand this and see them, but it'll, of course, round them to 3 decimal places. That's not helpful. These don't have decimal places. I want to round them to the millions, not the millionth. And so you can do that. Instead of rounding to 3 decimal places, which, by the way, I'm doing a lot of stuff quickly, and I feel in these early ones I should try to explain more. You can edit your cells in the cell itself over here, or you can edit up in this editor bar. Doesn't really matter. But if I want to do this, here I can click Learn More. Let's see if it actually tells us that this is possible. Yeah, it does. So here you can kind of see we've got this number, 826.645. And here in this extra help, it's giving you examples of like, how does this work? If we ask it to round to 0 decimal places, you get 827. If you don't put anything in for the decimal places, it assumes a default value of 0, so you get the same thing. If you put in 1, it rounds it to the nearest decimal place. So 0.645 rounds to 0.6. If I want 2 decimal places, it rounds to 0.65. 3 decimal places, like that, 645. But look at this, -1. That now rounds it to the tens. Not the 10th, but the tens, which is 830, right? So 826.645. If you round it to the nearest 10, then it's 830. If you round it to the nearest 100, we put in -2, it rounds to 800. So I could do that. I could use these negative numbers to round to the millionth place. And that means I'm going to have to put in -6, right? So now you can see the population of Alabama has been rounded to 5 million. I want to do that for all of the states. So I could extend this down and it will do that. This is something that we're going to be doing a lot of in this class, and I'm going to note it here now. When you have a cell reference like C4, and then you copy, Control Z, and then paste, Control V, or if you click this little button and drag down, then that cell reference updates. Because I dragged it down, it's changing the row reference. So it goes from C4 to C5, then C6, then C7. As you can see, this is super useful because that's what I want it to do. I want it to round these values for all these states. If I drag it over, you'll notice that now I'm getting 0. And that's because it is rounding 40.1. You can see the cell reference went from C4 to D4. Dragging it over a column changes the column reference by 1. And so rounding 40.1 to the nearest millions, which rounds to 0. So take note of that. That's how that works. So I could do this. I could keep doing this. I could drag this all the way down, get the rounded value for all of these. And now I could take instead the median. I'm sorry, not the median. I could take the mode. I'm bad at typing. Of these values. And it'll give me something now. The nearest, the most common one that appears is 1 million. That's interesting. Pretty neat. But I gotta calculate these all in a different spot and then take the mode of those things. Can't we get it all in one cell? Yes, we absolutely can. So here's what we'll do. Deleted those. So here we have this. What I could do instead is put round C4 to C55, grabbing all those. That didn't quite work. Even though I put in this whole range, C4 to C55, it only rounded the first value in that range because the function round is only supposed to take in a single value. That's what we put into it. In order for it to do this for all of the values in that range, we need to tell Google Sheets that we want it to break its own rules. We want it to apply this formula to every value in that range. And there's a special function in Google Sheets that does that, and it's called array formula. So array formula is going to take what we put in here and apply it to everything in that range. And you can see when I put that in, all of a sudden it does them all. So it computes all of these values and lays them in here. That's what I need to take the mode of. And so this is something that advice I often give when you're doing the spreadsheet assignments. Sometimes there's a big complicated calculation, and it's nice to just go off into these other cells and try to calculate it and then figure it out. And then once we have it figured out, how we can have a single formula get the rounded values for the whole set of populations, then we can just take that, we can copy that formula, and we can plug it in here. We're taking the mode of that thing. We can replace that thing with that formula. And there it is. And then we can get rid of this, and this still calculates. So this is what you're going to want to put in for the mode. We're going to take the mode of this array formula of the rounded values of the population where we've rounded them to the millions. So the -6th decimal place. Complicated. A little difficult. But opening up, hopefully, your horizon here, seeing how much a single cell of a spreadsheet can do. And so there we have it. Okay, now let's calculate the measures of dispersion. So this is the range, the variance, and the standard deviation. So range, that's probably range, right? Oh no, there isn't one. You notice there's this binom dist range, whatever that is. There's no function for range. We actually just have to do the math. So here's where we're doing a formula. We're going to use functions in order to calculate some values, and then we're going to do some math with them. So the range is the maximum value minus the minimum value. And we can just do that. The maximum value from here, if I do that, we can see is the population of California, 39,237,836. And then we subtract from that the minimum value. And the minimum value, I think, is Wyoming or something. Somewhere down here, Wyoming has 578,803. So that's what it's subtracting, and boom, there we have it, the range. So that is our function, our formula using the functions for the range. Okay, variance. Now we're getting into the good stuff. So variance, there's a function here called var. And that's what we're going to use. If I get rid of that parenthesis, you can see there's a couple of things in here. So we have var, but down here we have var.p and var.s. And in Excel, you're going to see these as well. Some with, I think, maybe the whole word variance. Var.s calculates the sample variance, which is when you divide by n minus 1. Var.p calculates the population variance. So if you have the whole set of values, the whole population of values, and you want to calculate the variance, you divide by n rather than n minus 1. And so that's a separate calculation. Var, without a dot, is going to be the sample variance, because that's almost always, 99.9% of the time, you just want the sample variance. So that's what we're going to do. So var of column C, boom. A huge, gigantic, bizarre number that's totally uninterpretable, but is measuring the dispersion. How far apart are these values from each other? In order to get it to something we can understand, though, we want to get the standard deviation. The standard deviation is, of course, just the square root of the variance. So I'm going to calculate that. You don't have to do it that way, but there it is. Of course, there is also a function. stdev is the function for standard deviation, and we could do that for column C and we get the exact same answer. So that gets us our sample standard deviation. Okay, this is what I wanted to do in these other ones. So follow along here with this. Just to show, like, this one function, how much math it's really doing. So we're going to calculate the standard deviation sort of by hand. So we are going to take each value here of the population and we're going to subtract from it the mean. Okay, this is important because we're going to learn our lesson here about dragging things down. If I take this, you can see this is a below the mean population, so we're subtracting a bigger number so we get something negative. If I drag this down, though, we run into some weird problems. Because now I'm taking the mean of Alaska and I'm subtracting the median. And then below it, I'm taking the mean of Arizona and I'm subtracting the mode. And then below that, I'm taking the mean of Arkansas and subtracting the range. Because when I drag these down, the reference is changed. And I don't want that to happen. I want this H3 to stay the same, no matter what. As we drag it down, it should always point to H3, because that's where the mean is. In order to anchor our cell reference, we use dollar signs. So on your keyboard, this is very different for all sorts of people. If you're on like a laptop, then a lot of times when you hit F4, so I'm going to hit F4 on my keyboard, you see it added the dollar signs for me. You might hit F4 and nothing happens. You might have to hit the function key, Fn, and then hit F4. And I think that's true on a Mac, but it's possible that it's like Command F4 or something like that. Play around with it, figure it out, or just add the dollar signs yourself. So if you don't have the dollar signs in there, you could just type in dollar sign here, and that'll do it. And we'll see now, as we drag that down, even all the way down here, it's pointing correctly at Louisiana. That cell reference updated, but this one didn't. This one locked in. And that's what we want. We want to subtract the mean for all of them. So I'm going to extend this all the way down to the bottom, where now we have every value where we've subtracted the mean. Here's a cool thing. So if I highlight this row, down here you can see some summary statistics, and you can see this, the sum and the average of this column is exactly 0. And that's what is special about the mean. It's almost the definition of the mean. The mean is the value that if you subtracted it from every observation, then the sum of those observations would now be 0. It's like recentered on 0 once you subtract the mean. So that's why the mean is, on average, the best possible guess for any individual value in the data set. Okay, so we have that. The next thing we need to do to calculate the variance would be to take all of these and square them. So I'm going to do an equal sign, click on this value, and then you do the little caret. 2 is how you square something. And so if I do that, I get this lovely suggested autofill, which is totally correct in this case. I do want it to just extend that down so that it is always just calculating the squared value of the number next to it. Cool, cool. Okay, now we're going to take the sum of those things. So that is a function. Sum is its own function, which will add together all of these values. We want to do that. We get a nice gigantic number that needs scientific notation. Then I need to figure out n, the number of numbers. This, we can use a function called count. Count will count up the number of numbers. And here, it's very smart. It's pointing at this number of numbers, but we could point at anything. We can also point at column C, and that'll get it right too. You'll see 52 is our number of numbers, because we have the 50 states plus DC and Puerto Rico. Then we're going to take that number and subtract 1 from it. So that's 51, of course. And now we can compute the variance. The variance is the sum of the squared differences from the mean divided by n minus 1. Hey, and look at that. These two are the same number. That's exciting. I can make this bigger so that we can actually see that it's the same number. We can even add decimal places to see for sure that it is, in fact, the exact same number. Wow, cool. I guess we want nice 2 decimal places. And then the standard deviation is just the square root of that number. And of course, we get the same thing that we get from the function. Okay, cool. That's hopefully convinced you that spreadsheets are awesome and not caused you to flail about as you constantly pause the video and go back and say, oh my gosh, what did he type in? And then you're just having a great time. 5-number summary. These are fun. So we calculated the minimum up here. We used it in this function here. We could calculate it a different way that I think kind of opens up what the 5-number summary is even about. So we're going to use the quartile function. The quartile function takes in a bunch of data, and then we're going to give it a quartile number. So Q1 and Q3, the quartile number is, of course, 1 and 3. But for the minimum, we're going to put in 0. And you'll see it totally gets it right. That if you say, what is the 0th quartile? Then the spreadsheet knows what you mean is, what is the smallest value? What would be the beginning number? And that's, of course, the population of Wyoming, 578,803, which it correctly identifies. So now, what I'm going to want to do, I could extend this down to these 5. It's going to calculate the same thing. But for Q1, I just want to change it to 1. And for the median, I can change it to 2. And check that out. The second quartile is the same as the median. We can confirm that those numbers are the same. And then the third quartile will put in 3. And to find the maximum, guess what? If you put in 4, you find the maximum, the population of California. So this quartile function is really just there to generate your 5-number summary when you put in 0, 1, 2, 3, 4. All right. Total population. So what is our total population for all 52 states? We can find that by just adding together all the numbers. We're going to take the sum of column C, and that gives us 335,157,329 people living in these 50 states plus DC plus Puerto Rico. Okay, now we go to a tough one. Average age. Well, shouldn't I just do average and then take the average of D, and so the average age is 40.01? No, that's not right. That's the average of the averages, which then doesn't weight things properly. Like California, they're a bit younger and they have way more people. And we're counting this 38.9 in the average, the same as we're counting, say, Wyoming's 40.0. They're 578,000 people. Way less people. To calculate the average age for the whole population, we need to sort of like reverse engineer the sum of all the ages of all 335 million people, which we can do because we know the average age here for Alabama was calculated by adding together all the ages and then dividing by the number of numbers, or the number of people, which is the population. So if I multiply these two things, if I do 5 million times 40, I get the sum total of everybody's age. And then I can add those up for all the states and then divide by the total population. That's a lot of work, though. Maybe we can use our array formula from the mode to do that multiplication for us across a bunch of things, or we could use a different function, a very cool function, one that I love, called sum product. Sum product is going to do that. It calculates the sum of the products of corresponding entries in two equal-sized arrays or ranges. So what I could do, I'm going to select C4 and C5, comma, D4 and D5. If I do that, we get this number. And what it's doing is basically this population times the age, the corresponding age, and then adding the population times the age for the next one. And you can see those are the same number. It's just taking the sum of the products. And we could do that, of course, across all of them. So instead of C4 to C5, we could do C4 to C55, all of them, and D4 to D55. You can't do C to C and D to D here because it will try to multiply the words by each other and then say, no, that's an error. You can't do that. So we got to put them in like this. But that gives us this total. If we add up everybody in America, all of their ages, we would get this. And so we just have to divide by the population that we've calculated here to get the actual average age, which is 39.82, not 40.01. This, I hope, is just quick. There's so many things that I hope you get out of these as we do them. And the thing I'm hoping you get here is sometimes you really actually have to stop and think about what you're doing. You can type in all these functions, you can do all this math, but the statistic that you're calculating, you might interpret wrong if you don't understand what it is you're doing. And so in this case, if we really wanted to interpret something as the average age, we have to do this more complicated calculation. Okay, could we get the average population when the average age of a state is greater than 40? And so we could kind of then see like, oh, our older states, are they bigger or smaller than the average state? To do this, there's a cool function that we call average if. So average if returns the average of a range depending on a criteria. And you can see this example in here. We're going to give it a criteria range and then tell it what we're looking for in that range and then tell it what to take the average of. So that's what we're going to do. So we're going to average if column D, oops, my bad, sometimes this happens, you get caught in the wrong thing. Okay, if column D has a value greater than 40, and because we have this greater than symbol, we need to put this in quotes. And it's smart enough, it'll be able to decode what that means. So if the value in column D is more than 40, which is what we wanted, average age greater than 40, then we wanted to take the average of the corresponding values in column C. And so it's only going to take the average of the states that have the average age over 40. And we see that's closer to 6 million, a little bit smaller than the average state. So in support of a little hypothesis we generated that actually bigger states are younger states and smaller states are older states, there's a little evidence here in the data to suggest that that might be true. Okay, now let's do a chart, because charts, we love them. They're going to be so helpful to us as we try to visualize data. I want to just get the total population in states that start with these letters. The easiest way to do this is just by hand. We're going to take the sum of all A through I. So that's Iowa, so D4. You know, sometimes this might pop up, this page unresponsive thing. Just click wait, and move on. So I'm working on it. I'm trying to get it to not do that. But it is a work in progress, and there's only so much I can do. It might just be a problem that always exists. So just click wait. Oh, popped up again. Just click wait and ignore it. Okay. So that's this one. So that is, oh, I did of age. I'm sorry. We want column C. We want total population, C4 to C19. Okay, then we can do the sum for the K's through N's. So that's Kentucky through North Dakota. So those ones. And then I can do the sum of O's through S's. That's here through South Dakota. And then the rest. Oh, but there is a weird part here, because not the rest. Puerto Rico is kind of out of order here. It's here at the end. So I only want to go to D54, and I want to add this in with the P's, which is through these O through S's. So all I'm going to do is just add it on the end. We got the sum of these O through S's, and then we'll add Puerto Rico in there. Cool. All right, then we can create a pie chart. So what I'm going to do is select these things, this table. So I'm like clicking and dragging to select this table. If you want, you can also select. Okay, there we go. We're back. If I can select these first parts, including the names, and then we're going to insert and then chart. And that's it. It's very smart. It knows I want this pie chart and plops it in there for me. And you can then get, a lot of nice little interactive things on Google Sheets to see how that forms out. Gives you the percentages. There it is. Charts and things, we'll do them as we go along. But that's how you do it. Insert and then chart once you've got your data selected. And if I update my grade, then I think I'll be at 20 out of 20. So we hope. Haha! Victory at last. And there it is. We're done with our first exploratory lesson. Don't forget to reach out to me. Here's my email address right here or right here with questions. All right, I'll see you on the next one.